Alright, in this video we're going to finish up sections 1.1 and 1.2. That's going to be lesson 1. And what they're having us do in these problems here is to find the domain and the range based off the graph. And so here's the graph we have for part C. And we're going to look at finding the domain. So the domain is going to be the far left to the far right. So how far to the left it goes is -4, including -4. And then you have the arrow on the graph here, which indicates that it's going to continue on to the right indefinitely. So it's going to go all the way off indefinitely, so we would say that goes off to infinity. Now the range is the same idea, but instead of going far left to far right, we're going to how low to how high. So the lowest that this graph gets is -2, and the highest it gets is going to be infinity. It's going to be a slow-growing graph, but it's going to get there. It's going to go off to infinity, and so we would say this includes -2 is the lowest, and it goes all the way off to infinity. Okay. All right. Let's look at example D. So example D, it looks like maybe we have sort of like a 4th-degree polynomial. So the domain's going to be far left to far right. So let's see what we got going on here. So the farthest to the left is at that open circle there, and we'll have to do a little bit of guesstimation. Maybe it's 2.1 or 2.2, but it is an open dot, so if we're going to, or open point, so we'd use a parentheses. So about -2.2, -2.1, somewhere around there. And how far to the right does it go? Well, this arrow indicates that it's going to continue on indefinitely, so this graph will continue on forever in the positive direction, so that's going to be infinity for the other endpoint for the domain. As for the range, we're going to go low to high. So the lowest this gets is -4, including -4, and the highest it gets, again, we have this arrow indicating that it's going to go up to infinity. So it goes up to infinity. And so there's our domain and the range. The other thing we're going to look at is the piecewise defined functions. And so here's what we got. So graph the following piecewise defined functions. So you should have done some of this in college algebra, so this should be a review. A is f of x equals x plus 1 if x is less than -2, and is equal to -2x minus 3 if x is greater than or equal to -2. So we're going to go ahead and do tables for both of the graphs. So on one hand we have y equals x plus 1. Okay, and when we're going to use that is when x is less than -2, and so I'd say -2 is like a transition point or whatever. So we're going to include it. We're going to include -2, and then we just got to determine whether it's open or closed. So at the end, at the connector points or the transition points, however you want to describe them, they'll either be open or closed. So if we evaluate this at -2, we get -1. Now, since -2 is not less than -2, this is going to be an open point here. So that gives us the point -2, -1. And now we just need to pick numbers less than -2, so probably -3 would be fine. So -3, if we plug that in, we'd have output of -2, and that would be closed as well. If you want to do another point, -4, you give us another point, -3. Now, if you're doing this on MyOpenMath, I think they only really want 2 points for a line, so you wouldn't do all 3 points. I would probably suggest you do the first 2 there, or the -1, -2, -1, and -4, -3. But don't use 3 points, because I think the extra point confuses the homework system a little bit. All right, so there we are. Okay, now let's do the other branch. So x and then y equals -2x minus 3. Okay, so we're going to start using this graph when x is greater than or equal to -2. So you have that connector point, -2. So at -2, the output is going to be 1. Now, -2 is greater than or equal to -2, so because that's true, we're going to have a closed dot, or closed point, at -2, 1. And then we, realistically, because y equals negative 2x minus 3 is a line, you only need one more point. So we'll evaluate at negative 1, and we get negative 1. And if you want to do another point, you can if you're graphing it on a piece of paper. If you're putting this on MyOpenMath, then only use 2 points for the line. Okay. So for me, because I'm graphing it on a piece of paper here, I'm going to do another point there. And so there it is. That's a graph of our piecewise defined function. And so we're just going to practice this on 3 more, and just different functions. So b is going to be f of x is equal to 3 if x is less than 0, and it's equal to the square root of x if x is greater than or equal to 0. Okay, so we're going to start off with to the left of 0, so that'll be y equals 3. Now 0 is the transition point, so we're going to use 0, okay, and the output here is 3. Now 0 is not less than 0, so that's not true, so we're going to have an open circle at our open point there at 0, 3. Okay, pick another number less than 0, like negative 1. Output is going to be 3. Output is always going to be 3. On MyOpenMath, you'd only want to put the first 2 points there, and then you graph your line. But since I'm graphing this, I'm going to do one more point. So negative 2 and 3, we've got a horizontal line. All right. Now let's graph the other one. So x and then y equals the square root of x, and the transition point is 0, so we're definitely going to include 0. Okay, square root of 0 is 0. Okay, and because 0 is greater than or equal to 0, this is going to be a closed dot or closed point. So we have the point 0, 0. Okay, and then this is the square root function. I don't remember how many points MyOpenMath would want, but just however many it asks for. So we're going to put 1, 1, and then 4, 2, and then 9, 3 as our points for the square root function. Okay, and that's graphing your piecewise defined function. Now, sometimes the piecewise defined functions will meet up at their transition points, but both of these have gaps or jumps. And in calculus, that'll be one type of discontinuity we look at. It's called a gap or a jump discontinuity. And so we'll say this is a jump or discontinuity, and we indicate what the x values are. So for part A, it's x is equal to negative 2 is where the jump discontinuity occurs. And for part B, the jump discontinuity occurs at x is equal to 0. Okay? All right, I got 2 more for you. Okay, part C, we're going to look at f of x is equal to x plus 1 if x is less than 1, and then it's going to look like x cubed if x is greater than or equal to 1. So we're going to start with the left function, or the first function, x is equal to, y is equal to x plus 1. Transition point is at 1, so we're going to include that. So if you plug in 1, you would get 2. 1 is not less than 1, so this is going to be our open point. 1, 0. And evaluate at 0, we get 1. Okay. And then 1, 2, and 0, 1, that's all you need. If you're graphing this on the MyOpenMath, I'm going to do one more point. So there it is. Okay. All right, now let's look at x cubed. So x and y equals x cubed. We're going to go ahead and start at our transition point of 1. 1 cubed is 1, and 1 is greater than or equal to 1, so that's true, so this is going to be closed. Okay, and then 2 cubed is 8, and so that's what we have. Now, this requires a little bit of knowing what that graph of x cubed looks like. So it's going to look like this. So don't connect them with a line segment, because x cubed is not a line. It's a curve. Okay. All right. And then part D, we have f of x is equal to negative 3x if x is less than negative 2. F of x is equal to negative 2 if negative 2 is less than or equal to x, which is less than 1. Or f of x is equal to x squared if x is greater than or equal to 1. So we're going to actually have 3 functions here. So the first one is y equals negative 3x, and we're going to use that when x is less than negative 2. So negative 2 is the transition point. So we're going to go ahead and include that there, and we get 6. Now negative 2 is not less than negative 2, so this is going to be open. Okay, and then because y equals negative 3x is a line, we only really need one more point here. So I can plug in -3 and I get 9, and I couldn't fit the next one on my graph anyway, so I'm just going to use those 2 points. Okay. All right. And now the middle function is y equals -2, and it actually has 2 transition points. It has one at here, let me redo this. Okay, it has 2 transition points. One, x is -2, and the other is x is equal to 1. So we're definitely going to include those. So at -2, the output is going to be -2. And because -2 is less than or equal to -2, that's going to be closed there. That's true. Okay, so we'll plot that point. And then I could, because this is a line, just jump to the next connector point, which is 1. But I'm going to go ahead and do -1 and 0. Okay, and then 1 is the other connector point or transition point, so 1 and -2, and that's going to be open because 1 is not less than 1. Okay, so if I were to be graphing this on MyOpenMath, I would just want to use these 2 points. Okay, alrighty, so there it is. And the last one we're going to look at is y is equal to x squared, and we're going to start using that at 1. So 1 squared is 1, and because 1 is greater than or equal to 1, that's true. This is going to be closed. Okay, 2 squared is 4, 3 squared is 9, and so that gives us those other points there. Okay, and so there is our piecewise defined functions, and these also have jump or gap discontinuities. Part C has a jump discontinuity or gap discontinuity. It's the same thing. X is equal to 1. And part D has 2 jump discontinuities. One at x is equal to -2, and the other one at 1. Okay. So theoretically, let's say this part right here was up here. Okay, something to that effect. Then we would not have a jump or gap discontinuity at x equals 1. It would actually be continuous. So if that were the case, then we would not have that jump discontinuity. Okay? Alrighty. Well, that's it for this video, and we'll see you next time.